Hi, welcome back. In this last video, we'll be talking about exponentiation mod m. We're looking for techniques to compute a to the k mod m for integers a, k, and m. As a running example, let's look at 3 to the 101 power mod 7. The first technique is called the method of repeated squaring. In the last video, we learned how to multiply numbers together mod m, which means it's straightforward to square a number mod m. A squared is equal to a times a. For example, 3 squared is equal to 3 times 3, which we can reduce mod 7 to give 2. It's straightforward to square once, which means it's straightforward to square twice. A to the 4th power is equal to a squared times a squared. So if we wanted to calculate 3 to the 4th power, we would take this 2 and we would square it. 2 times 2 is 4, mod 7. If you do this again and again, you can find any power of 2 through repeated squaring. When you multiply together a to the 2 to the I, and a to the 2 to the I, you get a to the 2 to the I plus 1. For example, 3 to the 8th is equal to 4 times 4. 4 times 4 is 16. 16 mod 7 is equal to 2. Now these numbers match. And that means if we square again, the pattern will repeat. 3 to the 16 is equal to 2 times 2, which is equivalent to 4 mod 7. 3 to the 32 is equal to 4 times 4, which is equivalent to 2 mod 7. 3 to the 64 is equal to 2 times 2, which is equivalent to 4 mod 7. So how is this helpful? We're going to use the fact that any positive integer can be written as the sum of powers of 2. We wanted to calculate 3 to the 101 power. 101 is equal to 64 plus 32 plus 4 plus 1, which means that 3 to the 101 power is equal to 3 to the 64 times 3 to the 32 times 3 to the 4 times 3 to the 1 using the laws of exponents. And we can just take those from above. 3 to the 64 is 4, 3 to the 32 is 2, 3 to the 4th is 4, and 3 to the 1, that's just 3. So 3 to the 101 is equivalent to 4 times 2 times 4 times 3 mod 7. Now we apply techniques from the previous video. 8 is equivalent to 1 mod 7, so 4 times 2 is equivalent to 1 mod 7, and 4 times 3, or 12, is equivalent to 5 mod 7. So through those calculations, we've shown that 3 to the 101 power is equivalent to 5 mod 7. So what did we do? We took this exponent, we broke it down as the sum of powers of 2. We then repeatedly squared 3 until we got to 3 to the 64th. Then we had all the information necessary to compute the congruence. Let's talk about another exponentiation technique that applies when the modulus is a prime number. This is called Fermat's little theorem, and it says that if p is a prime number, then for any integer a to the p is equivalent to a mod p. Furthermore, when a is not a multiple of p, then a to the p minus 1 is congruent to 1 mod p. And we already know that when an exponent is 1, that can be very helpful for simplifying product calculations. So what does this theorem mean? It means that the sequence s, that is a to the n mod p, repeats every p minus 1 entries. Let's look at that when a is equal to 3 and p is equal to 7. Fermat's little theorem says that 3 to the 7th is equivalent to 3 mod 7, and also that 3 to the 6th is equivalent to 1 mod 7. So if we write out this sequence, 3 to the 0, 3 to the 1, 3 squared, 3 cubed, 3 to the 4th, 3 to the 5th, 3 to the 6th, 3 to the 7th, 3 to the 8th, mod 7, we get a sequence 1, 3, 2, 6, 4, 5, 1, 3, 2, 6, 4, 5 that repeats every p minus 1 entries. So as an application, if we want to compute 3 to the 101 mod 7, instead of applying the technique of repeated squaring, we can use Fermat's little theorem, which tells us that 3 to the 6th power is congruent to 1 mod 7. The division algorithm says 101 is equal to 6 times 16 plus 5, so 3 to the 101 power is equal to 3 to the 6 times 16 times 3 to the 5. 3 to the 6th is equivalent to 1 mod 7, and so 3 to the 101 is equivalent to 1 times 3 to the 5th mod 7, which is 5. And we get the same answer that we had before, which is that 3 to the 101 is equivalent to 5 mod 7. One parting word, don't forget that you have other techniques at your disposal. Let's say you wanted to compute 19 to the 5th plus 20 to the 5th mod 21. The first thing you should see is that 20 and 19 are really close to 21, so 19 is equivalent to negative 2 mod 21, and 20 is equivalent to negative 1 mod 21, so 19 to the 5th plus 20 to the 5th is equivalent to negative 2 to the 5th plus negative 1 to the 5th mod 21. When we do that exponentiation, we get negative 32 plus negative 1 mod 21, or negative 33. We add 2 copies of 21 so that we are between 0 and 20. And so the final answer is that 19 to the 5th plus 20 to the 5th is equivalent to 9 mod 21. That's it for now. Take care.